Hello everyone. I will talk about a recent project we have with Boehringer Ingelheim. That's a migration project of a central compound management system to the state-of-the-art technology. So first I start with some details about the project with Boehringer Ingelheim. They had an existing compound management system based on BioVia iCentris as well as the direct Cartridge. They used it for their central compound management system worldwide. They had about 700 users. And the aim of the project was from a migration from a desktop client to a more modern web client, as well as a switch from BioVia backend technology to Chemaxon technology, mainly the cartridge. And the old system also was not a central repository. There were different repositories around the globe. And they want to have a central repository system. And one of also the key features of this project was the integration of a automated storage system from Cardex, and also interface with the other Boehringer Ingelheim systems. Another aspect was the integration of the Cd Catalogue, where people can use that for ordering their new substances. So after this election phase, they decided to use Quattro Research and our tool Quattro CM as the tool to go. And I give you some information about our company. So we are located in Munich, Germany, and we also have an office in San Francisco, US. We are currently about 35 employees, and we have more than 20 years of experience for IT solutions for pharma, biotech, and chemistry. And since, I guess, about 4 years now, we are Chemaxon partner as well. So our tool Quattro CM for compound management is just one of our tools. We also have an electronic lab notebook, and our solutions we also provide are in the area of antibody development workflows and biological registration systems as well. So some more information about our compound management system, Quattro CM. It's meant for handling and working with compound, centric for lab work. So you have barcodes on your vials or tubes. You can handle barcodes. You can use this with automatic storage systems. Especially for standard compounds, for companies, it's important to take care about their security aspects for their compounds. So these are also part of the tool. And they come with a shopping system where people can either order in-house compounds, or they can integrate with external catalogs for triggering and ordering workflow for buying compounds. So base of this Quattro CM is the concept that we have different type of concept that can be stored in the database. Most of them are typically chemical structures, but also non-structures or antibodies, cell lines, proteins, plasmids. Whatever you have in a lab can be stored and managed in Quattro CM. And the concepts are then mapped to the batch. That's the production of these various concepts. And in the end, you have different containers, small ones like well plates, or large ones with where you can store your compounds, and the system will track all this handling and management of these containers as well, for checking in, checking out, connecting with balances and barcode scanners and so on, to handle all the compounds in your lab. So the tool Quattro CM is now, since the beginning of this year, tightly coupled with Marvin.js as the default drawing tool and rendering tool for the chemical structures. And on the backend side, we support all major cartridges. But in this project, we used JChem for Oracle and the Corel cartridge from Chemaxon. So I will now highlight a few of the projects we had. So one issue was that we the project had want to migrate from a desktop application to a web application. I think that's because if with a web application, there's no installation required. Web applications are usually platform independent. You can run it on any device that can have a modern web browser. So it's also responsive. So if you have some mobile devices, the application will run as well. And so the minimal, the hardware requirement is very low. So because most of the heavy lifting is done on the server backend side. Web applications are cloud ready. So if you decide to have installation not on in your internal data center, you can also have the application running in the cloud. And also a chemical editor is included, like here in Marvin.js in the application. So there's no need to have an additional chemical editor installed on the user PC. So one of the highlights of this project was also the integration of the Cd Catalogue. The Cd Catalogue consists currently of 13 million compounds, and all these data have to be integrated with the about 200,000 in-house compounds to provide the user a common user interface for searching and browsing. And with the application, the user is able to search for structure, substructure search, but also text search for all the information that are stored with the compound, like the CAS numbers, the names, or INCHI keys. The user interface gives the user the possibility to also have searching for certain fields, for like example, a catalog ID, a department number, a location or whatever. And the user is also able to enter a list of identifiers, for example, a list of CAS numbers or a list of internal numbering to provide a user interface to have the result of this list searching. And in the end, the data can also be sorted and filtered further on. During this search and browsing, there are also some information that are calculated on the fly. For example, if a compound belongs to regulated compounds, or to have different vendor information if this compound is available or not. And all these information and calculation are site dependent because different sites might have different regulations for preferred vendor or how a compound, or if a compound belongs to a regulated compound or not. So if the user finds the compounds he wants to order, he sees if the different vendors are available or if the compound is still in-house available. And then he can trigger a shopping cart where the compound ordering process is triggered. But the system will also take care if this is, for example, also regulated substances, if this substance is, for example, toxic. And the system will also check if the substance is currently existing in-house to prevent multiple ordering of compounds that should be available in the organization. The shopping cart further on is then attached to SAP system for triggering ordering to the vendor. So one of also the parts of this project was the migration of the cartridge. The old system used the BioVia direct cartridge, and in the first step, we used the JChem for Oracle cartridge for working with the compounds and substructure searching and calculating properties. That works pretty well with more complex structures. However, when using of the large amount of data from the Cd Catalogue with 30 million compounds, we found some difficulties with trivial molecules. For example, if you're searching for benzene or aniline, the cartridge provides you a fast response, but that's very crucial that you are also creating a limitation of your result set, because then the cartridge will not work for a longer time to fetch all the thousands of millions of records. And we also found some difficulties with query optimization if you're using the cartridge on complex joins. For example, if I want to join my chemical structure search with catalog information, for example, restrict the result to certain vendors or whatever. So a few weeks ago, therefore, we started the evaluation of the Coral cartridge. And we found that it's very promising because we now have no limitation of the results that needed. So if the application stops fetching of the data, also the cartridge stops processing. Very interesting features we are finding that the Coral cartridge has the possibility to return the data ordered by relevance, so that for a substructure search, the compounds that are very similar to my search structure will the first hit of my result set. And on the other hand, also we found that the handling of complex joins work much better when you are joining your chemical structure search with other non-chemical attributes, for example, catalogs or information or whatever you have in your database. So you can here see the example, for example, for searching for aniline. So this is the result that we had when I used the Coral cartridge and searching for aniline, and you see that the similar structures of aniline are the first results I received from my substructure search. Another thing we see very promising is if I'm doing a substructure search also with a trivial structure like aniline, I can now join this with the ACD articles. That's about 40 millions, and the join works pretty well, and the result can be fetched in less than 1 second. So this is what we had really problems with the JChem for Oracle to optimize the query for complex joins. So as a summary, we see that the migration from Boehringer to our compound management system, Quattro Research, is the next logical step towards a modern compound management system. The Marvin.js is now tightly coupled into Quattro Research, and our tool of choice for drawing and rendering of chemical structures. We see that JChem Coral solves some problems of JChem for Oracle on large data sets with trivial structures, and we see that the return of the results ordered by relevance is really a great improvement of cartridge technology. And this is what we are very happy to see this as an outcome of our evaluation. So at the end, I want to acknowledge all the people that are involved in this project from Boehringer Ingelheim. This is Christoph, Thilo, and Georg. And on our Quattro side, it's Maya, Werner, Ina, Anne, and Christoph. All of them did a great job in the current project. And so I really want to thank you for their support and their work.